Ever wondered how airplanes survive lightning strikes mid-air? Spoiler, it happens way more often than you think. Airliners get struck roughly once or twice a year, and they're built for it. Here's the simple step-by-step breakdown of what actually happens when lightning hits a plane. Step 1. The setup. As a jet slices through charged air near a storm, the airplane itself can help trigger a lightning strike. The plane's nose, wingtips, tail, any sharp edge can concentrate electric charge. Step 2. The attachment. When the difference between the cloud and the plane gets high enough, zap. An attachment forms. Lightning usually latches on at a forward point, often the nose or a wingtip. You'd see a bright flash outside, and maybe hear a pop. Inside the cabin, lights might flicker for a beat, but that's it. Step 3. The path of least resistance. Electricity wants the easiest route. Airplanes are designed as a Faraday cage, conductive on the outside, protecting everything inside. The current skims over the skin, races along the fuselage, and exits at another extremity, commonly the tail or trailing edges. Step 4. The exit. You'll often find little scorch marks or tiny pits called arc spots at the entry and exit points. They look dramatic, but they're superficial, exactly what engineers planned. Step 5. Keeping the inside safe. Avionics, the brains of the airplane, are shielded and grounded. Wiring is routed and bonded so stray currents don't sneak inside. Those little combs on the back edges of the wings and tail, static wicks, they help bleed off leftover charge smoothly, so radio noise and static don't mess with communications. Step 6. What about composite airplanes? Modern jets use a lot of carbon fiber, which isn't great at conducting electricity. So manufacturers embed thin copper meshes and foils under the paint, bond panels together, and add metallic paths around doors, windows, and fuel systems. Result: the current still glides over the surface, not through the cabin. Step 7. Fuel tanks and safety. This part's critical. Fuel tanks sit in the wings, and they're protected like vaults. Joints are sealed, components are bonded, and parts that could spark are isolated. The fuel itself is treated to reduce static risks. Certification tests literally blast wing panels with simulated lightning to prove they won't ignite. Step 8. What pilots do. If lightning strikes, pilots run a quick checklist. They confirm that instruments and radios are normal. Keep flying the plane, and avoid the heart of the storm. Standard weather avoidance. After landing, maintenance inspects the entry and exit points, antennas and composite panels for tiny marks or cosmetic damage. Step 9. What passengers experience. A bright flash, maybe a loud bang, maybe a brief flicker. The plane doesn't drop, stall, or get fried. The structure and systems are purposely overbuilt for this exact event. How do engineers know it works? Airplanes are certified to strict lightning standards by the FAA and ASA. Manufacturers zap full-size sections in labs and even fly test aircraft into charged clouds to measure currents and fields. If a system can't shrug off a strike, it doesn't fly. Lightning can blow a hole through the fuselage. Not under certified design. Any marks are tiny and repairable. It turns off the engines. Jet engines don't rely on external electricity to keep spinning, and control systems are protected. It's rare, not really. It's routine and expected. So, can airplanes survive lightning strikes? Not just survive. Handle them by design. The current rides the exterior like rain on a windshield, the sensitive stuff stays safe inside, and you land with maybe a scorch mark and a story. Next time you see a storm near the airport, remember, the airplane is a flying Faraday cage with a plan for lightning from nose to tail. It's one of the rare times where struck by lightning sounds dramatic. But for modern jets, it's just another box to tick and keep flying.